As the need for renewable energy sources continues to grow, one company is working to meet this challenge with creative, sustainable solutions. Since 2006, Resource Recovery Technologies has worked to advance our economy and environment with innovative waste and recycling services. At the heart of these efforts is our state-of-the-art resource recovery plant, where waste is converted into fuel. This process involves extracting recyclable and non-combustible items from the waste and shredding the mostly organic materials that remain. This results in a product known as refuse-derived fuel, or RDF, which can be incinerated to produce electricity. Located in Newport, Minnesota, this plant processes more than 400,000 tons of municipal waste each year, providing enough RDF to power over 20,000 homes. Each day, the tipping floor of our resource recovery plant receives over 1,600 tons of municipal solid waste, delivered by approximately 175 trucks from throughout the region. Front-end loaders arrange this waste into piles and load it continuously onto the apron conveyor, where it will begin its journey through the plant. Some materials, like propane tanks and carpeting, present a hazard to the equipment, and the loader operators attempt to separate such materials from the waste entering the plant whenever possible. The apron conveyor consists of overlapping plates that create a continuous carrying surface for waste entering the plant. As waste enters the conveyor trench, it's the duty of the grapple crane operators to examine it for non-processable materials and remove them with the crane. Propane tanks and other pressurized containers present an explosion hazard to the plant, while bulky or stringy materials can jam or bind in the machinery. These rejected items are set aside. Processable waste is passed on to the inclined in-feed conveyor, which delivers it to the flail mill for the first stage of processing. Inside the flail mill, dozens of hammers weighing 150 pounds each rotate around a 9-ton rotor at a speed of 15 rotations per second. As waste is dropped into the flail mill, it is pulverized and shredded by the spinning hammers until it's able to fall through a grate in pieces no larger than 10 inches across. If an item of waste causes the hammers to jam, sensors alert the control room operator, who's able to deactivate the flail mill and assess the situation via a video monitoring system. The control room operator also has access to additional cameras located throughout the plant, as well as a master emergency stop button that can simultaneously deactivate all running processes in the facility. In order to transport waste and recyclables through the many operations required for resource recovery, our plant makes use of approximately 30 belt conveyors. These heavy industrial belt conveyors carry loose waste materials through the plant at very high speeds and range in length from less than 50 feet to over 300 feet. Each belt in use at RRT is equipped with a control station and pull cords that will deactivate the belt in the event of an emergency. Approximately 3% of the waste received at our processing plant is composed of ferrous metals, like steel and iron. To extract this recyclable material, waste exiting the flail mill is deposited onto a vibrating feeder belt, which passes directly beneath another belt lined with highly magnetized metal plates. As the waste items vibrate apart, ferrous metals are drawn upward, clinging to the magnetized plates above. As these items reach the end of the belt, the plates are demagnetized, causing the materials to drop onto a conveyor that carries them to a ferrous loadout trailer for shipment to a recycling center. Non-ferrous materials continue on to the end of the feeder belt, where they are dropped into the primary disc screen for further processing. Magnetic separation results in the collection of over 13,000 tons of recyclable ferrous metals each year. For materials composed of non-ferrous metals like copper and aluminum, which are not magnetic, RRT employs a unique eddy current extraction system. This involves passing the waste over a special conveyor that uses strong magnetic fields to impart an electromagnetic charge to metal objects within the waste. As these items pass over the head pulley at the end of the conveyor, they encounter a reverse charge which ejects them from the waste stream and into a separate collection chute. From here, they're carried by conveyor to a non-ferrous loadout trailer to be shipped to a recycling center. This results in the recovery of over 1,000 tons of aluminum and other non-ferrous metals each year, most of which is recycled back into new products within 90 days. Within the primary disc screen, waste passes across a bed of rotary discs. These toothed discs agitate the waste as they rotate, allowing smaller, denser items to fall through the 6-inch gaps between the discs and onto another conveyor. This serves to separate recyclable and non-combustible materials like glass and aluminum cans from the lighter organic waste that will become refuse-derived fuel. Later down the line, the waste is run through a secondary disc screen with 4-inch gaps, which helps to further eliminate non-combustible waste fragments. The primary and secondary air classifiers provide another means by which non-combustible materials are extracted from the waste. As waste is dropped from a conveyor into the separation chamber, a rising column of air causes lighter waste materials to float across the chute, ending up on a conveyor on the opposite side. Heavier items with small surface areas fall through the airstream onto a different conveyor. These rejected waste particles are referred to as residue and include materials such as rocks, glass fragments, and dirt, which cannot be burned or recycled. This material, which represents about 10% of all waste processed by RRT, is compacted into a residue loadout trailer for shipment to a landfill. Due to the varying composition and moisture levels of the waste entering the air classifiers, an operator continually adjusts the velocity at which air flows through the chamber to ensure optimum separation. The loadout yard contains all of the trailers into which the separated waste components are loaded. This includes open top trailers for both ferrous and non-ferrous recyclables, which drop into the trailers through a chute. Residue and RDF trailers feature enclosed tops and are filled using large horizontal compactors. As the trailers become full, yard tractors continuously haul them to a nearby staging area. From here, they are transported to their various destinations by haulers under contract with RRT. The rapid pace of production requires that yard tractor operators continuously replace the full trailers with empty ones as they are filled. Thanks to RRT's efficient resource recovery operations, the amount of waste entering our landfills is reduced by more than 285,000 tons each year. In fact, of the millions of tons of waste collected by RRT, a full 90% is successfully recycled into new products or converted into energy. RRT is proud of our unique contribution to a more sustainable future, and we are proud to have you join us in our success.